Now let's talk about amides and reactions with amides. First comes amidation. Well, this is actually when you combine a carboxylic acid and an amine. And when you do that, you form an amide bond. Amides are super important to biochemistry, which we'll talk about soon. So as an example, you could take a carboxylic acid like you see here, combine that with an amine, and that's how you get this amide bond. So this carbon that's in this, here, let me get a pen out. The carbon that's right here is the same one as the one that's right here. So to help you sort of keep track of things, I've tried to separate this out and do another version of this reaction. So if we look at the carboxylic acid and the amine, what is happening here is that we actually have a dehydration of these two things combining. So we have the OH from the carboxylic acid and a hydrogen from the amine, and that's what makes this water over here. So everything else that's part of that amine stays on like this and is part of over here. And everything that was part of this carboxylic acid up into that OH is still there as well, and that's where that stuff comes from. So sometimes it's easier to sort of see how it is that you're pulling things apart and why they get that way. You can also do this with secondary amines. You can't do it with like tertiary amines because you have to have a hydrogen in order to make this water. So if we do that with a carboxylic acid and a secondary amine, again, this is what's going to come out. And so it's a dehydration type of reaction. That's what makes your water. And then this nitrogen right here goes and connects itself over to where that hydrogen is, or sorry, where that carbon is. And that's where we get this new bond. So there is where the new bonds are, is right here. Okay, good. Now, this isn't so bad because these reactions are very similar to making esters. So I don't think that this is that bad. But where I see a lot of people struggle is where we start to take these two things apart. And it's not difficult to take the two things apart. The difficult part comes in the fact that most of the time we do it in either an acid or a base. So before I even show you the full reaction of what's going on here, let's talk about the fact that when you have any type of hydrolysis of amides, whether they be an acid or a base, if you tear them apart the same way that we just made them, you're taking an amide and you're going to turn it into a carboxylic acid and an amine, the same things that we just started with above. So this is kind of like, here's how you reverse this reaction. So if we have an amide that looks like this, what we are doing is we're cutting this apart and we're going to put an OH on this side and we're going to put an H connected to that nitrogen. So this requires water. So that OH is connected here, and that's how we start off with our carboxylic acid, and then the H goes here. That's how you get your ammonia in this case. Or we can do that with something more complex that has stuff on the nitrogen. It doesn't matter what's attached. We're just adding a hydrogen to the nitrogen. So we're going to cut this open. This side ends up with an OH. And this side, the nitrogen part, ends up with a hydrogen. So we make a carboxylic acid and we make an amine. Now, here's where the complex part comes in. After you do this part, then you need to take into account whether or not you're in an acid or a base, because acids react with amines, because remember, amines are like little bases, and they've got these little Pac-Man little doohickeys up here, and they love to grab a hold of an H+. Bases, on the other hand, react with carboxylic acids, because remember, a carboxylic acid has this wonderful hydrogen right here that can come off and make water. So let's look at some examples here. First things first, let me scroll this down to not get too much on the screen. We start by looking at what hydrolysis looks like with an acid. I gave you a big example here, but I'd rather show you instead this line because that's what I hope that you do. If we have an amide like this, we're going to add an acid, we add water, we add heat. In those three things together, in your mind, or at least I would put it on even on a piece of paper first, I'm going to separate it just like I showed you how to. Separate it into a carboxylic acid and an amine. And then go, aha, but we're an acid, and acids react with bases. And for that reason, I need to add a hydrogen to that nitrogen. Now, yes, it is also the case that if you're being picky, you'll find out that, yeah, you just made some more water. That kind of gets mixed in with this, and we don't worry about it too much. But if you want to write it, you go ahead. But see how we got this result here? That's the same thing as we get up here. If you can handle doing that all at once, you go for that. If you're like most people and you need to kind of take one step at a time with this, that is okay. Just giving you another example here. We have another amide. I drew in a different acid. It's still an acid. We've got water and we've got heat. With an acid situation, we're going to make the carboxylic acid, we make the amine, and then we have a positive charge to it. Again, I've separated that though, further down, and said first let's make our carboxylic acid and our amine, and then take into account we're adding the acid right there. So I separate first, add acid later. Okay, now the base hydrolysis with the amide is the same thing. The only difference is instead of ending up with a hydrogen that's extra on your amine, you end up with a negative charge on your carboxylic acid. So let's go through this. We have an amide and we have a base. Let me scroll down to the closer look version of it. Let's separate out our amide into a carboxylic acid and an amine. So here's our carboxylic acid, here's our amine. Then you have to keep in mind we're in a base. Bases eat up these hydrogen on carboxylic acids, and that's where you end up with that negative charge. Again, yes, technically, you're going to also generate H2O, but nothing to worry about there. You can write it if you want to. If you don't want to, that's fine too. Notice that I did the exact same examples here, so you can sort of see the difference between what it looks like in an acid and what it looks like in a base. So if you want to, scroll back up. And then here, I'm going to go straight for the closer look. We're going to take this guy, separate it into an acid and a base, or acid and the amine, excuse me. And then keep in mind, you've got a base here, and that's where this negative charge comes from. And my apologies, I should have said add base to both of those. And there we go. Thank you very much, and I hope that helps. There will be practice problems to do. You should try those. Thanks.